Hello everyone, I have received two email regarding this question that I have explained in my last video. So I'll quickly recording this short video just to explain my this question. So there was one mistake here that I said that there will be three row hazard, but actually there will be only two row hazard because the dependency between the first and the last instruction is it's not a it will not create any dependency, or it will not create any hazard. Yes, there is a dependency, but it will not create any hazard in a 5-stage pipelining. Now another point is, if you read up, someone has sent me this query. So this query, so it is important to explain me what he has written. Sir, you said right after read hazard will happen when we write before reading fully. Okay, so this is a, if this is a var hazard, he is saying if this is a var hazard, then why SD is considered a read operation. So this part I'm not completely understanding what you have written, but I think why SD is considered a read operation. SD is always a read operation, right? Here SD is reading x2. SD is not writing in s2. It is not a load operation. In case of SD, that is store instruction, here x2 is, we are reading the value of x2. That's why x2 is reading it here in SD is reading x2 and sub is writing on x2. Okay, so that's why there is a var hazard here. But next is written, if that's the case, then this is also var hazard. He is saying this is also var hazard, but actually this is wrong. You have to understand that you have to just check the program order. So this is program order, means sequential order: load, add, store and sub. This is the sequential order. So in real sense, in this order the program should execute, right? Even if you are executing in out of order, but ultimately the result should be in such a way that if you execute in parallel, then what, suppose I'm giving them number 1, 2, okay, 3 and 4. Okay, so if I run in sequential, then it is 1, 2, 3, 4, right? So the results that you are producing here in 1, 2, 3, 4, maybe you can run it in 3, 4, 4, 3, 4, 1. There may be many out of order combination, right? But in all these combinations, the actual output should be equal to this output. If it is not equaling with matching with this output, then your execution is wrong. And if you remember in class, I said that in out of order execution there are some algorithms that is called Thomas Solow algorithm, scoreboarding algorithm. These algorithm will make sure that maybe you are executing it in out of order like this, but the results that you are generating with any of this sequence, either it is this sequence or this sequence, the result that you are generating, this result must be equal with this result. There should not be any change in result at the end of this execution, otherwise it is not correct, because your ultimate goal is the sequential program, right? This is the actual the software engineer who will develop the software or develop the program. The software engineer will write his program to get this output, right? Sequential output. Now your processor is smart and you are doing it out of order, but that is not his problem. So what is his requirement is sequential execution. So maybe you are doing out of order execution, but ultimately you must why you are doing out of order execution? To just improve the performance. Performance तो ठीक है, but improving the performance, you should not compromise with what the requirement of the programmer. Programmer requirement है कि sequential execution होगा, isn't it? So maybe you will do out of order like this, but result should be same with the sequential one. Okay, this is the first point. Second point is why this is not a var hazard. So if you see, SD is instruction number 3, right? And add is instruction number 2. So we will not check hazard in this direction. We will check hazard only in sequential direction, 1, 2, 3, 4. So var hazard means right after read, right? Var hazard means right after read. It means that you in sequential order, if you see here in this 2, 3 and 4, so in sequential order, this 3 should first and 4 should come. 3 is first and 4 is in second, and 3 will follow, 4 will follow 3. So this is the program order sequence. This is a sequential order, right? So in somehow if you do 4 first and then 3, so that's why this you are violating the ordering. So suppose instead of this, if we are doing this, right, in this case, if somehow if you do this, during execution, then you are violating the order, right? So when you are violating the order, we have to make sure that we are doing out of order, right? So when we are doing out of order, we have to make sure that ultimate result should be same as sequential order. So if in that case it may not maintain the sequential order, because if you don't detect this war hazard, suppose there is no technique to detect war hazard, so what may happen that this sub in sequential order, see, this x2 should read the old value, right? This x2 should read old value, but in out of order execution, this this store will now read the new value. So that may not be correct. That may not be correct. So it means that for doing out of order execution, you are not getting the sequential output. So that's why in out of order execution processor, there should be a mechanism who will detect this type of hazard. This is called write after read hazard, right? And there are some mechanisms to handle it. One mechanism, as I said, that you can rename the registers and all, right? So that I have explained. Okay, and now one more thing is here. This question is why this is not a war hazard. So there is no question of thinking that this is a war hazard. Why? Because in sequential order, SD is not above add. In sequential order, the first add and then sub, right? So we will check only in this order. We will not check in reverse order. So in that case, in sequential order, this is not correct. In sequential order, first add is executing and then SD is executing, right? So in out of order, if SD is executing fast, so here if SD is executing fast, it means that if you go here, then see, first as per sequential order, first instruction 2 should execute and the value of x2 should update, and then the third instruction should read the updated content of x2. But now if here you are saying that if SD execute fast and then execute the add instruction, this is also wrong. But it means that the dependency here again come here in sequential order in these two. It means that SD should not read a content before writing by add. So this hazard is read after write. Read in SD after writing by add. So this is not a war hazard. This is a read after write hazard. This is a row hazard. That is the simple data dependency that we are saying. Now this is a row hazard. This is not a war hazard. I hope you are understanding it, right? So if I say 3 and 4, see, 3 and 4. So SD is reading and 4 is writing. 3 is reading, 4 is writing. So if you reverse it somehow and you move 4 before 3, then in that case you have to make sure that this sub sub is not writing before reading by that is the war hazard, right? Write after read. You have to make sure that if you are going out of order, then you have to make sure that the write is happening after read if you are going out of order. But here in these two instruction 2 and 3, if you go out of order, then in that case you have to make sure that the SD should read after writing by the add instruction. So this is a read after write hazard.